Welcome to another explainer. Today, we are taking a really dense, totally paradigm-shifting academic paper by Zhenfeng Cao and breaking down exactly why the future of tech is changing rapidly right before our eyes. I mean, the title of this paper alone is enough to stop any developer in their tracks: The End of Software Engineering. We are just talking about a cute new framework here or a slightly smarter code completion tool. No, we are looking at a fundamental restructuring of how humans and computers interact to solve problems.
Okay, let's unpack this massive claim right out of the gate. The source material essentially asserts that traditional software engineering is functionally ending. For over 50 years, the premise of software development has been exactly the same, right? A human engineer breaks down a problem, encodes that decision logic into static source code, and then manually updates that code the second the requirements change. But this paper argues that the era of explicitly writing out every single rule is actually coming to a close.
So the crucial takeaway here is that AI isn't just helping us write code faster. It's using code as an ephemeral, disposable instrument of reasoning. Really think about that for a second. In an agentic system, code isn't the final product anymore. A large language model understands a goal, writes a quick script to figure out a subtask, runs it, gets the answer, and then literally throws the code away. The code is just a temporary stepping stone. It's a tool the AI uses to think, rather than the permanent foundation of the system itself.
So here is our roadmap for today. 1. The complexity barrier. 2. Software's third paradigm. 3. We'll meet agentic engineering. 4. A much-needed reality check. And 5. The evolutionary roadmap.
Starting with Section 1, the complexity barrier. Decades ago, the legendary computer scientist Fred Brooks coined the concept of essential complexity. Basically, as software systems grow, the number of possible interactions between all the different components just explodes exponentially. But here's the fundamental flaw. Human cognitive capacity is fixed. We can only hold so many variables in our heads at once. That's exactly why large software projects inevitably slow down and become buggy. However, LLM-based agents can scale non-linearly. As we throw more training compute at them, their capacity to navigate this massive web of complexity grows in a way a human brain simply can't match.
Moving on to Section 2, Software's third paradigm.
Think about how the delivery of software has evolved over time. We moved from Software 1.0, local software where you essentially owned the headache. You bought a CD-ROM, installed it, and maintained it yourself. Then came Software 2.0, the cloud and SaaS era, where vendors managed that complexity for you. You just logged in. Now we're entering Software 3.0, Agent as a Service. This liberates you from even having to specify how a result should be produced. You just tell the agent what outcome you want, and the AI autonomously handles the complex execution.
But here's the catch with how we're currently doing things. Simply using AI to write static code faster still leaves humans as the bottleneck. It keeps the system's complexity ceiling completely intact. If you just use an AI to spit out a million lines of code that a human still has to read, test, and deploy, well, you haven't actually solved the complexity problem. You've just arrived at the bottleneck much faster. The true paradigm shift means eliminating the software artifact as an intermediary entirely. We need to go straight from agent to result, completely bypassing the traditional software lifecycle.
Which brings us perfectly to Section 3, Agentic Engineering.
There is a stark contrast between the old way and the new way. Instead of being a human code author writing pre-designed logic, you become an intent architect, guiding a runtime-generated reasoning system. In traditional engineering, your value is measured by how efficiently and correctly you could type out logic. But in agentic engineering, code generation is totally commoditized. Your real value comes from being the orchestrator. You are the person who designs the system, defines the big picture goals, and manages a digital workforce. At the absolute center of this new ecosystem is the LLM reasoning core. This acts as a control plane that dynamically spins up subagents, writes that ephemeral code we talked about, and retrieves long-term memories to solve problems. It's way more than just a text generator. It takes in multimodal perception, taps into memory so it actually remembers what worked yesterday, and then takes action. It might search a database, write a quick Python script, run it, observe an error, patch the script on the fly, and finally give you the polished result. The LLM is the brain orchestrating the whole shebang.
Because typing out code is becoming old news, your new high-value skills are going to shift drastically. We're talking about clearly articulating intent, calibrating quality, and maintaining ethical governance over these AI swarms. You'll need to be incredibly precise in how you communicate constraints to the machine. You'll need to architect exactly how different agents talk to each other and share memory. You have to build the frameworks that tell the agents what a good outcome actually looks like. And absolutely crucial, you'll be setting the guardrails to ensure these autonomous systems operate safely.
Okay, let's ground this theory in Section 4, the reality check.
The breakthroughs we're already seeing are staggering. For instance, coordinated multi-agent swarms achieved a 93% reduction in root cause identification time. 93%! This saved hundreds of engineering hours in a single month just by parallelizing investigations across 20 enterprise debugging workflows. Imagine having a swarm of digital workers that can instantly scan millions of logs, replicate environments, and isolate a bug in a fraction of the time it takes a human team. This isn't science fiction, folks. These are real efficiency gains happening today.
But it's not all perfect yet. There's a sobering reality check in a benchmark called EvoClaw, which reveals a dramatic 54% performance cliff during continuous software evolution. It's one thing to ask an AI to write a single function or fix an isolated bug. They're great at that. But if you ask an agent to maintain a complex code base over weeks, adding features, refactoring, and preserving the overall system integrity across dozens of commits, well, their success rate collapses from over 80% to just 38%.
So why the massive drop-off? Current agents suffer from context drift over large code bases, they cascade small errors, and they completely lack an awareness of long-term technical debt. As the codebase gets too big for their immediate memory window, they just lose the plot. A tiny mistake in commit number 1 turns into a massive, cascading failure by commit 10. Fundamentally, today's agents are very short-term thinkers. They just want to solve the immediate task in front of them, even if it means writing messy code that creates a mountain of technical debt for the future.
Finally, let's look at where we go from here in Section 5, the evolutionary roadmap.
The paper outlines a very clear timeline. We are currently transitioning from Stage 1, tool augmentation, into Stage 2, autonomy. And we're heading rapidly towards Stages 3 and 4, where entire multi-agent teams function like digital engineering organizations. Right now, most of us use AI as a super-powered autocomplete, right? That's Stage 1. We are just entering Stage 2, where agents can own a complete task from a specification all the way to a pull request. But by the end of the decade, we're looking at a world where you have a product manager agent talking to an architect agent, handing off work to a swarm of developer agents, all self-correcting without human intervention.
The old era of software engineering is ending. So the ultimate question you need to ask yourself is this. As code generation becomes completely commoditized, are you prepared to stop typing code and start orchestrating outcomes? The 10x engineer of the future won't be the person who writes the most elegant syntax. It will be the person who can clearly define intent, design evaluation frameworks, and lead swarms of AI agents to solve incredibly complex problems. The paradigm has officially shifted. Thanks for joining me on this explainer, and I'll see you in the next one.